Good morning, students. Today we will start chapter 18 tangents. A tangent to a circle is a line that intersects the circle at only one point. Suppose a circle with center O and line L intersects the circle or meets the circle at one point only. Suppose this point is P. At point P means the line and the circle have only one point in common. Then this line is called the tangent to the circle. This line is tangent to the circle. Suppose this line, another line passes through the circle like this. Line M. Is this also a tangent to the circle? No. Since the line intersects the circle in 2 points, the line is not a circle to a tangent because this line is second of the circle. So a tangent is a line that intersects or meets a circle at only one point. The point is called point of contact. The point where the line meets the circle is called point of contact. The line is said to touch the circle at point P. Now we will see some properties of tangents. First property. Suppose a circle with center O and a tangent line L which is tangent to the circle at point P. P is the point of contact. Okay. Now we draw a radius of the circle through point P. This OP is the radius, Okay. We have to find a relation between OP and L. If you measure this angle, you will find this angle to be 90 degree. Suppose this point is AB, then angle OPB is equal to 90 degree. Means the radius through the point of contact is perpendicular to the tangent. A tangent of a circle is drawn, a radius through the point of contact is drawn, then the radius and tangent both are perpendicular to each other. Means OP is perpendicular to L or OP is perpendicular to AB. Now we have to prove this property. How can we prove this? This is a theorem. In your book you will see this is a theorem. To prove this, we take a point. Suppose we take a point B on line L other than point P. On line L, P is already there on L. We take another point B on L and join O to B. Okay. Now, since B lies outside the circle, OB is greater than OP because OP is the circle, OP is a radius, P lies on the circle and B lies outside the circle, so OB is greater than OP. If we take any other point on L except P, OP will be the smallest. Here we will have to write one line. This happens for any point on L except P. It means if we take any point on L, okay, the line segment joining that point to the center will be greater than OP. Okay. So OP is the smallest of all the line segments from O to L. OP is the smallest of all the line segments that can be drawn from O to L. Now you can remember one property. Suppose this is a line M and this is point A. We are going to draw many line segments from A to M like this. And we have to measure all these lengths. This will be the perpendicular, will be the shortest. The shortest line segment will be the perpendicular to M from A. Using this property, we can show here that since OP is the smallest of all the line segments that can be drawn from O to line L, if we take another point like this is point Q, then OP is smaller than OQ. This we have said. OP is the smallest of all the line segments. OP is smaller than OQ. OP is also smaller than OB. Okay. So therefore OP is perpendicular to AB or OP is perpendicular to line M. Another property, one more property of tangents. A circle is given with center O and a point P outside the circle, not on the circle, outside the circle. Now from P we are going to draw tangents to the circle. We can draw two tangents. Suppose these points of contact are Q and T. If you measure these two line segments, you will find that PQ is equal to T. We say that the length of tangents drawn from an external point to a circle are equal. These two lengths PQ and PT are equal. We are going to prove this. To prove this, join OQ, OT and OP. You have just seen that the tangent and radius are perpendicular to each other, so this angle is 90, this angle is also 90. Now in right triangles, PQO and PTO, PQO and PTO. OQ is equal to OT. Radii, these are the radii of a circle. OP is equal to OP common. And both the triangles are right triangles. So these triangles are congruent by RHS. RHS. So by simplicity we get PQ is equal to PT. Okay.